OSPF stands for Open Shortest Path First. It is a routing protocol used in computer networking. OSPF helps routers find the best path to send data across a network. It is an Interior Gateway Protocol, or IGP. This means it works within a single autonomous system, or AS. OSPF is important because it is fast and efficient. It quickly adapts to changes in the network. This makes sure data always finds the best route. OSPF uses a link state routing algorithm. This means each router has a map of the network. OSPF divides the network into areas. Each area has its own routers and paths. This makes OSPF scalable. It can handle large and complex networks. In this essay, we will explore some key concepts of OSPF. LSA stands for Link State Advertisement. It is a message used in OSPF, which stands for Open Shortest Path First, to share vital information about the network. There are different types of LSAs, each serving a unique purpose in the OSPF protocol. Each type has a specific role, ensuring efficient and accurate routing within the network. LSA Type 1 is also called the Router LSA, and it plays a crucial role in the OSPF routing process. Router LSAs are created by every router in the network, providing a detailed description of the router's connections. They describe the router's links to other routers and networks, which is essential for network topology. Each router LSA includes the router's ID, the ID of the attached networks, and the cost of reaching those networks, which is a measure of the path's efficiency. For example, imagine a simple network with 3 routers, A, B, and C, each connected to one another. Router A will create an LSA Type 1 that lists its links to Router B and Router C, detailing the connections. It will also include the cost of those links, which helps in determining the best routes. This information is shared with all other routers in the area, ensuring that every router has a complete view of the network. Each router uses this data to build a complete map of the network, which is crucial for efficient routing. This helps them find the best path for data, ensuring that information travels quickly and efficiently through the network. By using LSA Type 1, OSPF maintains network stability and efficiency, adapting to changes dynamically. LSA Type 2 is known as the Network LSA. It is created by the designated router, or DR, on a multi-access network. A multi-access network is a network where multiple routers can connect to the same network segment, like Ethernet. The Network LSA describes all the routers on a multi-access network. It includes the network's ID and the IDs of all routers connected to it. The DR creates this LSA and shares it with all routers in the area. For example, imagine a network segment with 3 routers, A, B, and C, connected to an Ethernet switch. The DR will create an LSA Type 2 that lists all 3 routers and the network segment. This helps routers understand the network topology. It ensures that all routers have the same view of the network. This is important for accurate routing decisions. LSA Type 3 is known as the Summary LSA, a crucial component in OSPF networks. It is created by area border routers, or ABRs, which play a vital role in OSPF. ABRs are responsible for connecting different areas within an OSPF network, ensuring seamless communication. They summarize the detailed information from one area and efficiently send it to other areas, reducing complexity. The Summary LSA includes essential details such as the ID of the destination network and the cost to reach it, which is crucial for routing decisions. This summarization helps reduce the amount of information that needs to be shared between areas, making the network more manageable. It simplifies the network map for routers in different areas, allowing them to operate more efficiently. For example, imagine a network with 2 areas, Area 0 and Area 1, each with its own set of routers and networks. Each area has several routers and networks that need to communicate with each other. The ABR will create an LSA Type 3 that summarizes the networks in Area 1 and shares this summary with routers in Area 0. This way, routers in Area 0 do not need to know every detail about the networks in Area 1, simplifying their routing tables. They only need to know the summarized information on how to reach the networks in Area 1, which streamlines the routing process. This makes OSPF more efficient by reducing the overhead and ensuring faster, more reliable routing across the network. Section 5. Understanding OSPF LSA Type 4. LSA Type 4 is the ASBR summary LSA. It is created by area border routers or ABRs. This LSA is used when there is an autonomous system boundary router, also known as an ASBR, in the network. The ASBR summary LSA describes the location of the ASBR. It includes the ID of the ASBR and the cost to reach it. This helps routers in different areas know how to reach the ASBR. For example, imagine a network with 3 areas: Area 0, Area 1, and Area 2. There is an ASBR in Area 2 that connects to an external network. The ABR will create an LSA Type 4 that describes the ASBR and shares it with routers in Areas 0 and 1. This ensures that all routers know how to reach the ASBR. It is important for routing data to external networks. Section 6. Understanding OSPF LSA Type 5. LSA Type 5 is the external LSA. It is created by Autonomous System Boundary Routers, or ASBRs. This LSA is used to describe networks outside the OSPF autonomous system. The external LSA includes the ID of the external network and the cost to reach it. It is shared with all routers in the OSPF network. This helps routers know how to reach external networks. For example, imagine an ASBR that connects an OSPF network to the Internet. The ASBR will create an LSA Type 5 that describes the Internet as an external network. This way, all routers in the OSPF network know how to reach the Internet. This is important for routing data outside the OSPF network. Section 7. What is an ASBR? ASBR stands for Autonomous System Boundary Router. ASBR is a special type of router in OSPF. An ASBR connects an OSPF network to an external network. This could be another OSPF network, a different routing protocol, or the Internet. The ASBR imports routes from the external network into the OSPF network. It uses LSA Type 5 to share this information with other routers. This helps routers know how to reach the external network. For example, imagine a company with an OSPF network and a connection to the Internet. The router that connects the company network to the Internet is an ASBR. The ASBR is important for OSPF because it allows data to travel between different networks. This makes OSPF more flexible and powerful. Section 8. Function of ASBR in OSPF. The main function of an ASBR is to connect different networks. It acts as a bridge between an OSPF network and an external network. This is important for routing data outside the OSPF network. The ASBR imports routes from the external network into the OSPF network. It uses LSA Type 5 to share this information with other routers. This helps routers know how to reach the external network. For example, imagine a company with an OSPF network and a connection to another company's network. The ASBR will import routes from the other company's network and share them with the company's OSPF routers. This way, the company's routers know how to reach the other company's network. The ASBR makes OSPF more flexible and powerful. Section 9. Role of the Designated Router, DR, in OSPF. The Designated Router, DR, is a special router in OSPF which stands for Open Shortest Path First. It is primarily used in multi-access networks such as Ethernet, where multiple devices are interconnected. The DR plays a crucial role in reducing the amount of data that needs to be shared between routers. In a multi-access network, all routers have the capability to connect to the same network segment, creating a complex web of connections. Without a DR, each router would be required to share information with every other router on the network. This would result in a significant amount of network traffic, potentially leading to congestion and inefficiencies. The DR simplifies this process by acting as a central point of communication. For example, imagine a network segment with 3 routers, A, B, and C, all connected to an Ethernet switch. In this scenario, router A is elected as the DR based on specific criteria such as priority and router ID. Consequently, router B and C will only need to share their information with router A rather than with each other. Router A will then take on the responsibility of sharing this information with router B and C. This method significantly reduces the amount of data that needs to be shared between routers. As a result, it makes the network more efficient and less prone to data collisions. The DR is therefore an essential component of OSPF in multi-access networks, ensuring smooth and efficient communication. Section 10. Conclusion: Importance of understanding OSPF concepts. Understanding OSPF and its key concepts is important for anyone working in computer networking. OSPF is a powerful and efficient routing protocol. It helps routers find the best path for data. It is used in many networks around the world. Knowing about LSA types, ASBRs and DRs helps you understand how OSPF works. This knowledge is useful for designing and managing networks. It helps ensure that data is routed efficiently and accurately. In conclusion, OSPF is an essential protocol in computer networking. Understanding its key concepts makes you a better network engineer. It helps you design and manage networks that are fast, efficient, and reliable.